let's welcome our second speaker, Physiopy.
Hi, everyone. I am Sarah Goodale, and I'm a member of the Physiopy community. So Physiopy is a Python suite that was built to handle physiological data that's recorded during neuroimaging settings. So a lot of what we do is fMRI, but these could be used broadly if you are interested in something else. So who is Physiopy? Essentially, in the past 5 years since we've been founded, we've amassed over 30 contributors from 24 different institutions all over the globe. And this is really exciting for us because we're all volunteers, we're all from all over the place, and it's a really great place to network, to contribute to different projects. Here's a little list of some of the universities that we do have with us. One of them, the MIP lab, is now at the University of Maastricht in the Netherlands. But you can kind of see a glimpse of where everybody's from. A lot of us are here at this conference, so if you see one of us, please come talk to us if you're interested. We also have our first Google Summer of Code mentee for 2024, so we're really trying to get a lot more contributors, developers. If you're interested in this, definitely reach out to us. So why Physiopy, or how did we get started? So when we first started the toolbox, the exploration of physiological signals with functional MRI or neuroimaging was still pretty niche. Now it's a lot more well-known, but there is definitely still reason to expose the topic, to get more people into the field, because there's still a lot of questions to be answered and a lot of ways to process the data that could be better interpreted. And so, like I said, we would love to have more researchers, clinicians interested in the topic, interested in joining us. We are big into sharing physiological data as open science, providing toolboxes, documentation, and we use a community-driven, bids-based open development approach with our toolbox. So the core components are, we want to build a set of easily adoptable toolboxes, have clear and approachable documentation, and build community practices based on a consensus. So the idea of community practice for us is essentially we get our whole entire group together as best as we can every month, but we do these community practice meetings every other month. And the idea is to bridge topics that are either controversial or tough to understand from just the literature, what is out there. And we try to build a best way to go about and approach these topics, whether that's from setting up your acquisition, collecting data, processing your data, using it with fMRI, cleaning it, whatever that might be. And then lastly, we are a community of users, developers, researchers, all interested in physiology. All of these interplay together. Everybody that is involved is not only involved in one of these, we're involved in all of them. So it is there's a very good interplay across all of these. The current libraries that we have are set up in the streamline that you see here. Essentially, you collect in one unit or one acquisition file your raw physiological signals with your imaging modality. For us, a lot of us, it's fMRI. And then one of the things that we do is we want to make sure the data is in BIDS format when it comes off the scanner, whether it is or not. Some of you may be familiar with BIDS format, others not. We have a great function called phys2bids that helps you put it into BIDS format, which I'll talk about in a second later. And then after that, we run through peak detection, which is I'll talk about in a minute as well. Phys2denoise, which helps us denoise the data. And then we're also developing a quality check toolbox that basically allows us to go through the signals, make sure that they look good, everything's clean, and then they are ready for physiological analysis or for any kind of analysis with the fMRI data. And then the documentation that we build kind of on the top overarches all of these different toolboxes, and it essentially allows us to provide good, approachable ways to understand all of these, to interpret all of these, and ways that you can have your best foot forward when collecting physiological data. So the first one is this bid-defined physiological data, so Phys2bids. This was the flagship repository that was established in 2019. And really the whole aim of this is to put the physiological data that you collect into BIDS format so that it is compatible with any of your neuroimaging modalities. And it's currently supported by a lot of different acquisition software and hardware. So whatever you do collect, we'll probably be able to use it in this tool and put your data in the BIDS format. And this is kind of a little example of one of the outputs that you would see. Essentially shows you some of the raw images of the files that you're collecting, and then you checks if it's in BIDS format and does some other checks, and then eventually puts it out in BIDS. And we actually have a great tutorial that if you were interested in, we can show you over on the side really briefly afterwards for a couple of these. We also have really good tutorials on our website, so I highly recommend, which I'll show in a little bit, on our GitHub website, there's some tutorials where there's data provided, the scripts are provided, really easy to download, go through the instructions, and learn how to run the code. This one has a lag, so bear with me between the slides. There we go. So the next one is peak detection. So when you collect physiological data, a lot of the time when you use the data to clean your fMRI signal or for whatever it is for, one of the big things that we're interested in is these peaks. So essentially the peaks of the amplitudes that you're collecting of the waveforms. And so peak det, or peak detection, was donated by Ross Markello, and it's currently just been maintained by Physiopy. So that's another option if you have physiological tools, you're interested in collaborating with us, we can do our best to maintain those and move forward. So if you are working in physiological data in any capacity, please do reach out. The aim is essentially to have an automatic and supervised peak detection process in a completely reproducible manner that then allows you to detect peaks and go through and make sure that everything is looking good with your signal. So this is just a little example of what the interface would look like. The signal's popped up, it shows you the peaks. You can choose to either select or deselect peaks if they're actually physiological or not. Requires a bit of trial and error, knowing people that have gone through physiological data, but that's part of what our community is for. You can have people help you with that if need be. The next toolbox is Phys2D noise. So this is kind of in its alpha stage. It's one of our newer codes. It's started in 2020, and we still have a lot more work to do, but it is functional, and it supports denoising your cardiac data, or denoising your fMRI data using cardiac and respiratory. So if you work with fMRI at all, there's these derivatives of the physiological signals that you can collect that essentially help interpret the fMRI data in certain degrees, and some of those from your pulse ox, which is the infrared scanner or monitor that goes on your finger, is heart rate, and then respiratory variation from the belt that's placed on the people in the scanner. It basically captures their movement of breath. So we can actually use these to look at signals of interest in the fMRI data if we want to. So this is, it's in the alpha stage, partially tested, but it does work. So if you are interested in this, we do encourage you to give us feedback, check it out, and provide ways for us to make it better. And then the other piece that we've been really working on this past year, and we are really excited to actually announce to you guys, is our community guidelines. And so essentially what this is it's a website, as you can see here down at the bottom, the Read the Docs. And it's essentially the importance of acquiring physiological data, whether it's for noise, whether it's signals of interest, why should you care, motivation for caring, whether it's to model and remove it, to model a relationship with neural signal of interest, remove high frequency noise, and also just to monitor the state. You can get a lot of information from physiological signals, so it's very important to consider that in your fMRI data. And we also go into great detail on the setup, the data collection, the data processing, how you can use this. We would love to have feedback. It was launched maybe a few weeks ago, if I remember correctly, so please check it out. Please put an issue on GitHub if you think something's wrong. If you have information to contribute, reach out to us because we would love to have you join. So the last thing, or toolbox that I'll mention really briefly, is PhysioQC. So we've really taken advantage of the brain hacks here at OHBM. If you have not been involved, it's a great thing, so please do get involved. And this project actually started last year at Brain Hack. Essentially, it came out of a need to develop a method to process and quality check your physio data. There was really no great way to do it. There's a lot of toolboxes that do go through physiological data, process it, but really nothing that gives you a really clean and nice view of what that quality looks like. And so we started this last year, and basically this year with the help of Celine, Simon, and Blaze, who I know Celine or Blaze I at least see in this group. They basically put forward a version 1 of our workflow, and it gives you a bunch of multimodal variables. So whether it's cardiac data, respiratory data, you can have plots of standard deviation, the mean, peak detection. Here you can see some of those. A cool new quality check function for respiratory data that checks the quality of breath. As you can it looks kind of blurry for me over here, but essentially what it does is it goes through the respiratory waveform, and then it'll tell you the quality of the potential breath, and if it's wrong, you can potentially remove that or scrub that or clean that however you would like. The workflow is finalized, at least for right now, so we have a way to output all of these images. We're currently working on a way to get an HTML9 report out for you so that it would be nice and pretty and all put into one PDF for HTML. And so that is all I have. I just want to thank you to all the contributors to Physiopy. Like I said, if you at all want to get involved, We are a very community-driven group. Everything that we do is through a consensus. We're very active on Slack. We meet monthly, whether that's to develop code, to talk about community practices. Even if you've never been a developer before, we love new people. We have a really nice and welcoming group. And I have stickers, if anybody wants. So please come find me for stickers. And then we do have a poster. It is 2275 Wednesday and Thursday. So come check us out or chat with us. Like I said, a lot of us are here. And thank you.
Thank you, Sarah. Is there any question? Okay, we have one question here. Are there any Physiopy output on base example report? Repository.
The question was about outputs on the Physiopy repo. So we do have, I mentioned it for PhysDebids, but we have a peak detection and I think potentially also a phys2 noise tutorial on the website. So the outputs are provided through those. Peak detection, the documentation is really well done, so you will see a lot of really great output. The GIF that I showed in the slides is on there. So it depends on the toolbox you're interested in. We try to give good documentation, provide outputs and those kinds of things, how to interpret them. If it's not there, let us know. We can try to make it better.
I have a question. Mm-hmm. First of all, thank you for such a good tool development and all. I was just thinking, do you also have extension to analyze the EMG data which we acquired inside the scanner?
EEG data?
EMG.
EMG. We do not have anyone that I know of that collects EMG. I'm looking back at somebody else. We do. EMG? Like with EEG? Yeah, okay, we do. We don't have any, that I know of, people or code in the Physiopy toolbox, but we do have people that collect EMG. I'm not sure who it is, but we can connect you if you need somebody to talk to about that.
Then I will.
So yeah, come find me afterwards, and I'll figure out who actually does collect EMG.
Yeah, sure. Thank you. Thanks a lot.
Thank you.
Did you already throw your really great work and great talk, thanks, on some standard data sets that acquired physiological and different the standard measurements and to see how the quality given your measurements is an average? So in principle, it's like a prototype quality of Physiopy data, of physio data to relate to if you have your own study.
Yeah, we've tested it a lot on our own data sets. We have not, are you talking about like open data set? Have we tested for reproducibility and those kinds of things? Not from a large open data set standard, but we have from like our community, our internal collection data sets, and we do have really good reproducibility across those. But
great, and is there some quality that I can say, okay, mine is not bad, let's say, or mine is good, that you have ratings or anything like this?
We don't, actually. That would be a great thing to incorporate. Yeah, thanks for that. Mm-hmm.
And great work.
Thanks.
Any more questions? If no, let's thank Sarah again.